16. We got that cell problem. Let's go and talk about number 16. What type of electrochemical cell is this? So we don't see a battery. We're going to say it's a galvanic cell. Galvanic cell, voltaic cell, no battery. All right, if we're going to say it's a galvanic cell, that means we're probably going to have a positive amount of energy coming out here. This is probably like our cell phone battery, where we get constant charge on our phone until it completely runs out. It's going to give us a positive amount of energy. We can see the screen, it's got energy. So picture your cell phone battery is this, okay? Now, it's got two environments, all right? And they express that with these equations, all right? So if they want to do it properly, they need to give us two reduction equations so we can get 2 volt values. You cannot get a volt value from an oxidation equation. So what they did was they switched that around here already for you. They gave you the oxidation reaction, 0 to +2. They had to do that because reduction always happens at the cathode. Okay, this is our cathode. We'll talk about that in a second. So let's talk about number 16. Let's say no power source. Okay, fine. Number 17. The anode. Let's look at our electron flow. Our electrons are flowing away from this iron bar. They're flowing away from this iron bar. Okay? They're flowing away from this iron bar. So let's represent that in this equation here. Let's talk about what's going on in this solution with this equation. Okay? They told us something kind of funny here in the box. They said they had an aqueous FeNO3. This NO3 is part of our salt bridge. It's going to keep our ions balanced. There's a positive ion here, there's a negative ion here. It's going to keep things balanced. So they're going to tell us this solid bar of iron is going to lose 2 electrons this way. So let's write that. 2 electrons it's going to lose this way. And then we're going to be putting in solution, aqueous, in solution, Fe2+. All right? Now, you told me before that this NO3 has a negative charge on it. If this is a negative and there's a positive 2 here, we probably want 2 NO3s to balance that out. Is that what we have in our equation, or in our box here? We sure do. So we just proved that happens here with this equation. Let's go over here now. Let's talk what's happening here. Our electrons are flowing over here. They're coming towards our cathode. This is our cathode. All right, this is our anode. Away, coming towards, we're catching our electrons. Cool. So let's represent what's going on in the environment by our equation. We're told we have Fe. We're told we have Fe3 plus aqueous. We're told we have Fe2 plus aqueous. The reason why we have that is because they're going to be attracted to these electrons. They're going to plate this bar. They're going to go onto it and plate it. They're going to do like some sort of chroming, plating, gold plating. I've never heard of like plating before. That's what we're doing right now. We're plating something. So these electrons, or these iron ions, are going to be attracted to this negatively charged cathode. Okay, so let's go ahead and tell what's going on here with number 19. Where is the 2 connecting to these? It's the salt bridge. Okay, fine. Number 20. What species is getting oxidized? Species is being oxidized. Let's look at our oxidation reaction. Fe0 goes to Fe2 plus. Fe is being oxidized. Fe is being oxidized to 2 plus. All right? So there's number 20. Where does reduction occur? Reduction always occurs at the cathode. Fe3 plus to Fe2 plus. Reduction always happens at the cathode. That was number 21. Let's see if we can do 22 together right now, or we can do the next problem. What happens to the iron electrode as redox reaction progresses? Let's see what happens here. Our iron electrode, this solid bar of iron, is going to lose ions, and it's going to lose electrons. So it's probably going to lose mass. Since these electrons have some sort of mass, they're going to lose them. Let's look at letter B. It loses mass as the iron metal is consumed by the reaction. I like that. Let's go to number 23. What happens to the platinum electrode as the redox reaction progresses? So let's look over here. You see how these iron ions are attracted to it because it's got negative? It's probably going to gain mass. So it's going to gain mass as the iron metal is plated onto the electrode. Okay? So that's number 23. So let's do number 24 together right now and do the net redox reaction. So let's talk about these two together. Let's put these right here. This is my oxidation, where it's right here. Fe0 goes to Fe2 plus 2 electrons. And we're going to use this equation, Fe, let's write that in red. Fe3 plus E goes to Fe2 plus. If we want to add these two together, we got to make sure our electrons match. They don't. Let's multiply this by 2. Let's multiply this by 2. Let's multiply this by 2. Our electrons match. Let's add them together. Our electrons cancel out. Let's bring this down. Fe0. Let's bring it right here. Fe0. Okay. We have our arrow. Let's go down here. Plus 2 Fe3 plus. Electrons go away. Let's go back up here. Goes to Fe2 plus. These electrons go away. We have a plus 2 Fe2 plus. Since these are the same charge, we can add them together. So we're really going to say this is 3 Fe2 plus. Okay? So let's go ahead and rewrite this. 3 Fe2 plus. And there's our net redox reaction. This is our net redox reaction. Let's go and put our states in here. Solid, aqueous, aqueous. Now we're completely done. That's number 24. Let's do number 25 together right now, the shorthand method. Shorthand method, remember we had our cheat. Let's go ahead and do our cheat, okay? Let's go ahead and do our cheat. Let's start with our basic cheat. We're going to say we have a salt bridge, and we have an anode, and we have a cathode. And then we said that something always happens at the cathode. What always happens at the cathode? What always happens at the cathode? Reduction always happens at the cathode. Okay, reduction always happens at the cathode. So if we're going to say that, and reduction, this is oxidation, we can go ahead and put our reactions right here. This is my oxidation reaction. This is my reduction reaction. I need to start with my anode. I need to go to my cathode. Let's go ahead and put everything in its own box based on its state. We start with the anode. We do Fe not solid. That's its own state. It goes to Fe2 plus. Then we have our salt bridge. Let's put that here because that's where our salt bridge is. Then we go to Fe3 plus, comma, Fe2 plus, because they're aqueous. Aqueous. Same phase, same box, all right? We do not see a cathode in our reaction. We need to end our shorthand with the cathode. If we don't see it here, let's go find it here. PT, there is our shorthand. That's our shorthand method. That number